All right, so good afternoon, everyone, and we'll be discussing the Leetcode weekly contest solutions for today. Okay, so the contest number for today is 382, weekly contest 382. I'm recording this video on 28th of January, and the time at the moment is 12:16 p.m. So yeah, just walking you through the contest, summarizing the difficulty of the contest from my perspective, I would say that again, the first three problems were simple problems, fairly on the medium side this time. Like in the last 2 weeks, we have observed that the problems were more towards the easy side. But for the first three problems for today, it was more on the medium side. And the last problem was again very difficult, difficult than what we have seen in the last two, three contests. So, and if we see the marking scheme for today, it's pretty obvious from the marking scheme that the fourth problem had to be a very difficult problem. So the ideal approach for solving this contest would have been if you wanted to perform good in a contest. Of course, you should try to solve all the four problems, but it's not always possible for everyone to solve all the four problems in the given time span. So solving the first three problems in, I would say, 15 minutes would have fetched you a very good rank of under 500, I would say. So yeah, let's start with the discussions for the contest. Okay. So for the first problem, let's see. Let me just open the whiteboard as well. Yeah. Let me just test my whiteboard first. Yeah. Okay. So we are discussing weekly contest created. Okay. So, all right. Yeah, so let's move on to the first problem. So we have been given a zero index string typed by a user. Changing a key is defined as using a different key from the last used key. Okay, that means if we are using a different key on our keyboard, then only we can say that we have changed a key. Okay, let's see an example. For example, AB has a changed of a key from A to B, while capital B, small b does not have any. Okay, so this is very important. So what they're trying to say is if I type uh, B and then I put my caps on and then I again type B, so that is not a change, okay? So the capital and small letters coming consecutively would not mean a change coming, okay? So only if we are using a different key, then only we can say that, yeah, it's a change. So we need to return the number of times the user had to change the key, okay? So we have been given a string, and we need to count the number of changes as described in the question, okay? You can read the note. So again, this is what the note means, that shift or caps lock operations wherein you can switch from a small letter to a capital letter won't be counted as a change. Okay. So we see a first example, A, capital A, small b, capital B, C, capital C. Okay. So this would have two changes, from capital A to small b and then from capital B to small c. Okay. So we need to count the changes only. So I'll just, it's again the simplest problem. So I won't spend a lot of time on this. I hope everyone would have solved this. So let's see the approach for this question. Okay, problem one. All right. So we have been given a string. Okay, let's take the example only. A, capital A, small b, capital B, small c, capital C. So now the observation for this question is, if I just take two consecutive characters, okay, and if I check their lowercase or uppercase, okay, either one of them, and if that comes out to be if that comes out to be different, then I can say that there is a change. For example, if I take lowercase of a and lowercase of b, if this is not equal, then I can say that this is a change. And similarly, I can either ways check the uppercase as well. So I can check if capital of A is not equals to capitals of B, so this will again be a change. Okay, so this is all you need to do. So it will be like a simple for loop, okay, going from 1 till n, alright, and checking if s of I, you can do upper or lower. Okay, so I'll take upper for the time being. Uppercase of A is not equals to uppercase of I minus 1. So I'll compare it with my previous factory. You can compare it with the next one. In that case, you'll have to start from 0 and you'll have to go till less than n minus 1. Okay, so it's up to you. If this condition holds, so I'll make a change variable and I'll increment it and I'll return it. Okay, simple. So this is how we'll be coding this solution. The complexity for this code would be O of n because we are iterating for the string, and space complexity is O of 1 because we are not using any additional space apart from the variable. Okay. So let's see the code for this question. It's a pretty simple code, so I just initialized my answer variable for storing the number of changes. I'll iterate over the string from 1 and I'll check the uppercase of the ith character and I'll compare it with the uppercase of I minus 1. If they are not equal, then I'll increment my answer variable and I'll return the answer. Simple as that. Pretty simple code, so I hope everyone would have solved this question. So let's move on to the next problem. Okay. Yeah. This is the next problem. So we have been given an array of positive integer nums. We need to find a subset of nums which satisfies the following conditions. You can place the selected elements in a zero index array such that it follows the pattern x square, x4 till some x power k, and from that point it starts reducing. Okay. From x power k it reduces to x power k by 2, then some more powers, and then finally it reduces to x only. Okay. So we need to find the maximum number of elements in a subset that satisfies the condition. Okay. So if you observe, let's take a next page for this problem 2. So our array would go something like this till some x power k, and then it reduces down to the same one. So this is like a mountain structure it's making from x, then x square, then x power 4, okay, and will reduce to x. Similar to this one only. Wait. Yeah, this is how we'll be going. All right, so yeah, let's see an example. 54122. Okay, okay, so what we are doing, think about this. Okay, so let's take a base case. Uh, let's say we want to let's say x is one. Okay, if x is one, so it wouldn't matter how many powers we are taking because any power raised to one would be one only. So we only need to count the frequency of x, or sorry, frequency of one in our given array. Okay. And keep that in mind that the final array should always be odd in size. Okay. Because you're doing x power k. Every other element, x power k by 2 is coming two times. X power 4 is coming two times from the beginning and from the end. So only x power k is coming once. So 2 plus 2 plus 2 plus something like this plus a 1 for x power k. So the size would always be an odd number. Okay. So these are the two observations. Okay. Now let's just think about the approach for this. This is more of a mathematical approach. Okay, a very important observation is from the constraints which have been given to us in the question. That is 10 power 9. Okay, 10 power 9 is a very important what do you call as very important observation in this question because if you just increase your power, if you take any value greater than 1, integer values, so let's say I take 2 only, okay, and if I check 2, then 2 power square, 2 power 4, 2 power 8, so if you go this way, and your numbers should be between 1 to 10 power 9. So at max, you'd be able to take 10 elements only. This is the most important observation from this question, that the maximum length you can go for is 10. So yeah, that is again, this is how now the question for complexity doesn't come into picture now. So we can easily solve this question. We can easily write for nested for loop kind of a solution because the nested loop, the second for loop or the second while loop which we'll be having, it will have a complexity of O of 10 in worst case scenario. So that would be constant. So our solution would reduce down to a O of n solution. That is for iterating for an array. We can even make further improvements. Let's discuss that. Okay. So yeah, now we have made all the observations. Let's just pen them down here. Let's see if we can make a solution. Okay. So I'll just note them down here. Okay. So the first observation for one, the case of the number one. Okay. Second observation was size always odd. Okay. And the last observation that we have is that maximum length can be 10. Okay. So it's not a very big number, so you can easily write a nested solution. Okay. Most of you would have left this solution because you would have thought that we are writing a nested loop, so it's going to be n squared. That is why I always say that understanding complexity properly is very important. Not every nested loop has a complexity of n squared. Okay, and that is why I always try to make you understand that n is nothing. It is just the number of iterations that you are making. N is not a significant number in itself. It is just the number of iterations that you are making. So if we are just making 10 iterations, so O of n would reduce to O of 10, which is a constant solution again. Okay. So now what we'll do is think about this. From this, what you can do is, let's say we store the elements in a map. Okay, like frequency, integer, comma, integer, something like this, like a frequency map. Okay, frequency of all the elements. We iterate over the array and we store it in a frequency somewhat like this. Okay, so now when we have the frequency, now think about this that you can iterate over each element. Okay, and yeah, you can go on checking that. Let's say if I iterate over my map, let me move on to the next page. Okay. So when I'm iterating for my map, okay, x comma y colon frequency. Okay. So if x is my current element, then I can iterate from x and then I'll check if my map has x square with a frequency of greater than 1. Okay. Sorry, not greater than 1, greater than 0. Okay. Then I'll check for x power 4. Then I'll check for x power 8. And till what will be the conditions for checking this? That whatever number I'm checking, it should, let's say, yeah, this x some power w. What is the current power which I'm checking? It should be less than or equal to 10 power 9 and the frequency of this value should be greater than 0. This is what my nested loop would have a condition, and I'll be using a while loop, not a for loop. Okay, because I do not know how many iterations I'm making. I just know the upper limit for it, that is 10. Okay, and what I'll do inside this is like the first loop. Okay, this is my, let me use a different color. So this is my first one, and this is my nested while loop. Okay. Now, what I'll do inside this is that think about this. Okay, yes, okay. You'll check firstly if the frequency is 1. Okay, if this value comes out to be 1, then we know that we have reached the end. Okay, because if this is 1, I cannot take any value greater than this, like any part greater than this, because even if I take that, okay, then where will I add it? Because this value has frequency 1. So this is the peak of our this mountain if you think about it. So this is our peak. Even if I try to go somewhere here, where will I add this value? Because this has to be added and this can only be added at the peak, so I'll have to reduce from that point only. Okay, so this is one. We'll break out of the loop. Okay. Before this, what I'll do is I'll increment a count variable for maintaining the current size. I'll do this. I'll change my x to x into x as stated. Okay. And I'll reduce the frequency to zero. I'll reduce the frequency to zero because now I have used this element. So I cannot use it again for any other element. So I'll mark it as zero now. Okay. And after coming out of the loop, I'll just take the max value of answer. Okay, so I'll do max of answer, comma, count. That is what I'll do. And I'll just return this. Okay, I'll just return this. Simple as that. Okay. Now let's move to another page and let's discuss this again. I think my writing was very bad. So this was our first loop. Okay, for iterating for map. Okay, okay. And this will be somewhat a while loop with all the conditions which I had mentioned. Okay. And somewhere here, I'll take the case of one. I'll check like this was my x comma f. So I'll check if x is one. Okay. So I'll take the answer for x here only. I'll maintain an answer variable, even initialize it to one because worst case scenario, maybe you will always have the answer one. You can always take a single element. Okay. Inside the while loop, you will write those conditions which I stated in the last one. Okay, and you'll update your answer variable here from to count if it is greater, if count is greater than answer. Okay, and you will return answer. So the complexity would come out to be, if you see that let's say we have all the different elements, which is not the case. So worst case scenario mein, this will have a complexity of O of n. Okay, this is O of 10. Okay, and these are all O of 1 operations. So no need to counter for this. So the complexity would come out to be 10n, which is only O of n simplicity. And the space complexity is O of n because we are storing our elements in the map. Okay, so this is how we'll do it. Okay, let's see the code for this quickly. We have a map, we maintain the frequency, we initialize the answer, we iterate over the map, we check if the current element is zero. ठीक है? If the frequency is zero, because you see I'm marking the frequency to zero somewhere here. So I'm trying to avoid unnecessary iterations again. So I can mark this as zero. Even if you do not do the step, you will still, मतलब the solutions will still get accepted. Okay, no problems. So yeah, we'll mark this condition. Then I'll take the current element. Okay. Now let's discuss the case of one. If x is one, so what will be my answer? My answer will be the frequency of x, that is np of x minus, I need to check if this is odd or even. If this is even, so I need to subtract 1 from it because remember that we discussed at the beginning that the size has always to be an odd number only. So if this is even, so I'll have to subtract 1. If it is not, then I need not subtract anything. Okay, and then I'll mark this as 0 and I'll continue from here. Now let's discuss the actual case, that is the count while case, the main case, if x is greater than 1. So I'll initialize count as 0. This is the upper limit which I had set, 1 e power over 10 power 9, and the frequency should be greater than 0. I increment count plus equal 2 at every step. I check if my MP of x is 1, so I'll break out. Okay, at that point only. Else, what I'll do is I'll mark the frequency as 0 again. I'll change my x to x into x. Okay. Coming out of the loop, again, I'll have to firstly check if by any chance I have counted all the elements twice because you see, I'm always doing count plus equals to. So this will always be an even number. So I'll have to do count minus minus. So I'll check this case. Okay. And I'll update my answer and I'll return my answer. Simple as that. Okay. So if you run this, this will get accepted. Oh, let's try this again. Okay, so this is accepted. So I hope this should be pretty clear to everyone. This was a fairly difficult, not difficult, fairly on the medium side of questions. I would say that the third problem was more simpler. was simpler as compared to this question. So this was a more complex problem. So let's move on to the third question, which was again a pretty simple problem. So Alice and Bob are playing a turn-based game on a circular field surrounded by flowers. The circle represents the field, and there are X flowers in the clockwise direction between Alice and Bob, and Y flowers in the anti-clockwise direction between them. Okay. So Alice and Bob are playing a game on a circular field. On the clockwise side, they have X flowers, and on the anti-clockwise side, they have Y flowers. So the game proceeds as follows. Alice takes the first turn. In each turn, a player must choose their either the clockwise or the anti-clockwise direction and pick one flower from that side. Okay. So the player would take a turn and he or she can pick up a flower from either of the sides. Okay. At the end of the turn, if there are no flowers left at all, the current player captures their opponent and wins the game. Okay. So let's say if there are let's say Alice's turn and Alice picks up the last flower now. Okay. So now that there are no flowers left and Alice is the current player, so she'll capture Bob and she'll win the game. It goes like that. So let's see what we have been given. We have two integers n and n. The task is to compute the number of possible pairs x comma y that satisfy the conditions. Alice must win the game according to the described rules. Okay, so it's like we want to only consider the cases wherein Alice is winning the game. The number of flowers x in the clockwise direction must be within the range 1 to n, and the number of flowers y in the anti-clockwise direction must be within the range 1 to n. Okay, so they have said that x can be any number between 1 to n and y can be any number between 1 to n. So we need to return the number of possible pairs. Okay, okay. So let's take an example. N is 3, n is 2. So the following pairs are 1, 2, 2, 1, and 3. Okay. Now, if you think about this, you will get it. Okay. Now, again, this is, as I said, this is a very, very simple problem. So let's see, this is some mathematics only. Now we need to only consider the cases when Alice is winning and Alice is starting the game. That also we know. So, yeah. Now, if you think about this, uh, observe this that Alice can only win if the total number of flowers, that is x plus y, is odd. Okay, is odd. Okay, this is the only condition when Alice can win. So we need to now we have one thing that we need to only take the cases where x plus y is 1. Sorry, x plus y is odd. Okay. Now what will be the two cases? Either x can be odd or it can be even, or y can be odd or it can be even. Out of these possibilities, what we can consider, we can take x odd and y even, or we can take x even and y odd. So it will be like x odd y even or x even y odd. This is the only two possibilities we have, okay, for the numbers. Now it's pretty simple now. Okay, what you can do is let's see the constraints as well once. Okay, because we need to write a O of n kind of solution. The power is 10 power 5, the maximum value. So it's very simple now still. Okay. What you can do is you can iterate for all the values of x from 1 till n. Okay. And you can build some mathematics around it. Let's say if x is odd, if odd. So how many possible values of m can be taken? Okay. Think about this. This is important. Matlab, this is again simple mathematics. Most of you can do this on your own. Okay. So let's say if x is odd. So let's say if x is odd, then we need to take y as even. Okay. Now y for even. For that, again, we'll have two cases. That is if m is odd. If m is odd. So how many number of even numbers can be taken? Let's say if m is 5. So if we take 1, 2, 3, 4, 5, that is 2 and 4. So that is m by 2 numbers. Okay. And if I want to take if even numbers, yeah, huh. If I want to take the case when m is even. So we'll again have m by 2 numbers only. Okay, so you can make all the cases around. A general suggestion would be to make all the cases. Do not try to write an optimized code here, because when you will be in the contest, you should only try to get the solution accepted as soon as possible. There is no point in being over smart and try to write a generalized formula, and then you end up making a lot of errors. So you can just simply write if m is odd, m odd, else, that is m even. And similarly for if I is even, and you can build two cases. This would be the best approach for this question. Okay. So let's firstly discuss the complexity here, and then we'll see the solution, because it's again a mathematics based solution, not much to discuss here. Complexity is O of n, okay, or you can even take O of, yeah, this is O of n, or you can take O of, you can do it this way as well, minimum of m comma n. That is, whichever number is smaller, you can run the loop for that number, and for the inside the calculations, you can use the greater number. The space complexity is O of 1. Okay. Now let's move on to our solution. So it's again a pretty simple solution that, as I said, we'll initialize an answer variable iterating from 1 till n. Okay, I'll check if I is odd. If m modulus 2, that is m is odd. So think about this, for I modulus 2, that is I is odd. You'll have to take y as even. Okay. So how many even numbers we have from an odd number? That is m by 2. And how many even numbers we have from an even number? That is again m by 2. Okay. Else we take the case if I is even. This is just a small modification here. That if I is even, that means you have to take m as odd now. Okay. Like sorry, you have to take y as odd, because x is even, now y should be odd. So for y to be odd, if m is odd, then you will have m by 2 plus 1. Okay, think about this, that if m is 5, so how many odd numbers are there? 1, 3, 5. That is 5 by 2 plus 1. Okay, so yeah, else again it is m by 2. So if you just run this, you'll get the solution will get accepted. And again, this should be a pretty easy problem. In fact, it was, I would say, easier than the second problem. So yeah, yes. So yeah, let's move on to the final problem, the most difficult problem for today's contest and what I've seen in the last three, four contests. Okay, you should have a good knowledge of bit masking to understand the solution. Okay, let's read the problem statement. We have been given a zero index integer array nums and an integer k. In one operation, you can pick any index I of nums such that I should be between 0 to n minus 1, and replace nums of I and nums of I plus 1 with a single occurrence of nums of I and nums of I plus 1. And here means the bitwise and. Okay. So in one operation, we have k operations in total. And in one operation, we can choose any two consecutive elements, and we can replace those two elements by their bitwise and. Okay. So we need to return the minimum possible value of the bitwise or of the remaining elements of nums after applying at most k operations. Okay, so we should apply at most k operations, and after applying those operations, we should get the minimum value. Okay, of bitwise or. Okay, so you should be pretty clear with what bitwise or and bitwise and are. Okay, and we need to return the minimum value. So let's move on to this problem. Okay. Problem 4. I'll just point out the observations I have made for this question, and then I'll show you the solution, because lot of it for this question would depend on how well you understand bitwise operations. Okay. So this is how we'll discuss that. Okay. Think about this now, that you have to maintain the minimum value. So, and let's see the constraints as well. If you see the constraints, they have said that nums of I is less than 2 power 30. So they have explicitly written 2 power 30. That means you have 29 bits. Okay. All right. So what you try to do is, you'll always try to, first observation is that we'll try to minimize, yeah, or decrease the max set bit. Okay. Think about this, that Ideally, greedily, what I'll do is I'll have to set the maximum, this thing, the most significant bit to zero. I'll have to try to set it to zero because in the bitwise OR operation, even if a single element has the maximum, sorry, the most significant bit as one, so it will be counted in the answer. Okay. So this is the most important observation that you will have to set that value as zero. Okay. Why we would do that? Let's take a case for that. If I take this as bitwise number 8, 0, 2, 4, 8, and if I take this number, so this is again, this value comes out to be 8 and this is 7. So if you see that the first three bits, even if we set them, the total value does not is still the total value would still be less than this single bit set. Okay. So this is why we need to reduce the maximum, the most significant bit to zero. Okay. Next observation is that, again, think about this that let's say if I take the most significant bit j, okay, I count those numbers, I make a count of those numbers which do not have this bit set. Okay. Let's say this is variable count. Okay. Array size is n. Okay. This is not having jth as 1. Okay. These are those numbers. So how many numbers are left which have jth as 1? That is n minus count. Okay. Now we want to apply the operation on all these numbers. Okay. Right. If we want to do any operation, we'd like to do it on these many numbers. Okay. N minus count number of numbers, okay, because these numbers are having this value as 1, their jth bit as 1. So if this value, if k is greater than equal to this value, then only you can apply the operation. If it is not the case, that means if this value is greater than k, then you would always have jth bit as set, you cannot avoid that. Okay, so this is the most important observation, and this you have to do for all the bits. Okay, this now your task is left to do replicate this for all the bits. Okay, so it will be like we are running j from 30 till 0. Okay, minus minus kind of operation, so it will be a reverse for loop, and we'll do the checking for every jth bit. If this count variable we define here for every bit, if n minus count, if this value is greater than k, okay, yeah, then you will have to include the jth bit to answer. You cannot avoid it. Okay. Else you can avoid it. Simple as that. Okay. Now a lot of you would have this question that, sir, how are we checking for the remaining elements? Okay, if I said the, chalo, I have checked for the jth bit and I have removed that. Okay, from the answer. तो बाकी बिट्स के लिए भी तो कुछ चेंजेस हुए होंगे ना फॉर ऑल द बिट्स बिकॉज वी वुड हैव परफॉर्म सम ऑपरेशन एंड उनसे भी तो कुछ चेंजेस आए होंगे ना उन्हें भी तो एनकाउंटर करना होगा दिस इज व्हाट यू नीड टू चेक think about this is the again an important observation that we'll only have to check one bit and we can check the subsequent bits in subsequent operations. Okay, in the subsequent iterations only we can check because अगर बाकी bits को भी zero set होना होगा तो वो आपको आगे मिल ही जाएंगे उनके लिए भी same condition hold हो ही रही होगी right अगर उन्हें zero set होना होगा and अगर उन्हें नहीं set होना होगा तो फिर आप नहीं कर सकते उन्हें right simple as that. So this is again an observation and you can return the answer for this. Okay. So let's see the code for this because for difficult problems it is very, you see, it's as I always say, a lot of it would depend on how well you have prepared for the contest, how many problems you have solved. Okay. Then only you will be able to understand my intuitions. So we have a size of the array, we have the answer variable. Okay. We iterate as I said from 30 to 0th bit. I take the count variable, okay, current value, okay. Now this is how I'm counting it. We'll do for all the current. This is basically all the last bit set, okay. Target element देख लेते हैं. What we have as target is because we want that what do you call that as that the last element, yeah, the most significant bit, that is the jth bit should be 0. So I'll do answer till this point bitwise or of 1 j minus 1. So this number will have all the bits from 0 to j minus 1 at index as set. But the jth one will be 0. So I iterate over the array. Okay. Now, sorry, iterate over the vector. I do a bitwise and I check if this value, if this condition holds, current or target is equal, this is equal to target. You can do a simple operation as well for this. You can simply just check it for the jth bit, if for this number if the jth bit is set or not. That would also work. Okay. So this value is equal to target. Current bitwise or of target is equal to target only. So this means that the jth bit is set. So sorry, the jth bit is not set. Okay. So in that case, you will increment the count and will set current value. Okay. Same operation. Okay. Because again, you'll have to understand this a bit. Okay. And coming out of the loop, you'll check if n minus count is greater than k. Okay. And if this value comes out to be greater than k, then we cannot avoid it. Okay, we'll have to include the jth bit to our answer. So I'll include it to my answer and I'll return my answer. Now, if you just run it, you'll get a correct solution. So you can try running this. Okay. So yeah, the complexity for this is, let's see the complexity. Yes. The time complexity is O of 30n because we are iterating over the 30 bits here and we are iterating over the array somewhere here. So this is O of n. So this is a nested 30 into n. Again, this is O of n solution. Space complexity is O of n because we are not using any additional space apart from the few mask variables and answer variable. So yeah. And yeah, this ends the discussion. Now let's summarize this problem as we usually do, all these problems. So the first problem I would say was 1 out of 5. Second problem was 3 out of 5. Third problem was 2 out of 5. As I said that the third one was easier as compared to the second one. And the last problem, I would say today it was somewhere 5 on 5. So yeah, you should have solved the first three within let's say 15 to 20 minutes at max. Yeah. And yeah, for the last problem, again, it would depend on your practice and your concepts clarity. So this ends the discussion for the contest. I would ask all of you to like, subscribe, and share my channel. Share these videos with everyone. So this would give me a lot more motivation to make more such videos because now it's very difficult to make all these videos when you are doing a full-time job as well. So yeah, please share it with everyone so that I can have more feedbacks from everyone and we can work on including a lot more series like this. So I was thinking about adding a series on my most favorite lead code problems, which helped me a lot in my interviews. But I only want to add those things when I have a good audience and I have a lot many people listening to me and all those things. Okay. So please like, subscribe, and share and feel free to leave your comments in the chat section and your suggestions as well. So, till that time, happy learning. Have a great weekend. Goodbye, everyone. Okay.